Section 1.7 is our introduction to decimals. We get more decimals in section 1.8. I put a little chart at the top of this page just because we need to know the place values for numbers. And to the left of a decimal, it's ones, tens, hundreds, thousands, and so forth. To the right of the decimal, you get the th, tenths, hundreds, thousands, 10,000s, and so forth. We're going to be asked to write numbers as decimals, and I'll keep this handy because it's real helpful if I have this chart place value if I don't have it memorized. So just jumping right into the section, the first few problems ask me to write 5 as tenths, hundreds, thousands, and 10,000s. Super easy to do this. If I want to write 5 as a tenth, I'm going to take the number 5 and just put it in the tenth position. So I have a decimal, and then to the right of the decimal in the tenth position, I'm going to put a 5. That would be an adequate answer, but usually we slip a 0 so the decimal doesn't lead off a number. It's good practice to make the decimal not hidden. For part B of number 2, I want to do 5 hundredths. So I'm going to take the 5 and put it in the hundredths position. So I have a natural decimal, a tenths position, and then the 5 goes in the hundredths position. When we're writing a number as a decimal, we fill up zeros all the way to the decimal point. So that is considered 5 100ths. And generally, I don't leave decimals first in a number. If there's nothing left, I sneak a 0 in. For part C, to do 5 thousandths, I'm going to take the 5 and write it in the thousandths position, which is the third decimal position. So I'm going to have a decimal, space, space, 5. And to the left of the 5 in the hundredths in the tenths position, I'm going to fill it up with 0. That's 5 thousandths. And I'll probably sneak a 0 to the left of the decimal again, just because it looks nicer to me to do it that way. And lastly, 5 10,000ths, I'm going to take the 5 and put it in the fourth decimal place, which is the 10,000ths place. So I'm going to have 1, 2, 3, fourth decimal place is a 5. The tenths, the hundredths, and the thousandths position get zeros, and then I sneak a 0 to the left of the decimal. Next page, more of the same, just 2-digit numbers as opposed to 1-digit numbers. 4a wants me to write 18 100ths. That means the 8 part of the 18 needs to go in the hundredths position. So I'm going to write my decimal. I'm going to put the 8 in the hundredths position. Now instead of filling in zeros to the left of it, I have the 1 from the number to fill in. And I've used all the decimals. That's the decimal part. Since there isn't a whole number part, maybe I'll sneak that whole number 0 and put it into the left. For part B, to do 18 thousandths, the 8 is going to go in the thousandths position, which is the third decimal position. So I have decimal, first decimal, second decimal. In the third decimal position, I'll put an 8. I need the 1 preceding the 8 to get the 18, and then I'm going to need that 0 to fill in the tenths position. So for an answer to part B, I'd probably write 0.018. For part C, to do 10 thousandths, the 8 needs to go in the fourth decimal position. So there's a decimal, tenths, hundredths, thousands, 10,000ths. The 8 goes in the 10,000ths position. I need to get the 18 part of it, so I sneak the 1 in. I need zeros after the decimal and the blank spots, and usually I sneak a 0 to the left of the decimal as well. I actually write this right. So 0.018. 0.0018 is what I should have said. I was having a clumsy time writing that. And then 1800 10,000ths, the 8's going to go in the fifth decimal place because that's the 100,000ths. 1800 thousandths. I'm not even sure what I said there. 1, 2, 3, 4. So the 8's going to go in the 5th decimal or the 100,000ths position. The 18 is going to happen when I precede the 8 with a 1. And then I'm going to sneak in a couple of zeros. Maybe write the answer without the little underlines, although I could live with the underlines. And that is 18/100,000ths. We're doing this just because we're going to round in a little bit, and knowing your place value is good for rounding. For 6 417 10,000ths, the 7 needs to go in the 4th decimal or the 10,000ths place. So I'm going to have 1, 2, 3, 4 decimals. I need to precede the 7 by a 1, precede the 1 by a 4. When I have blank spots, I fill them up with zeros. So the decimal equivalent of 417 10,000ths is 0.0417. And then for the next one, it's 100,000ths. So this is going to go, the 1 there is going to go in the 5th decimal position because that's the 100,000ths position. So I need a point. I need 1, 2, 3, 4, 5 decimals. The 1 at the end of 411 there goes in the last place. Fill in the 411, add a couple of zeros, and I'm going to get the decimal for this is 0.00411. That's 411 100,000ths. Checking my answers to make sure I'm not having any mind collapses and putting an error on the video, which means I gotta reshoot the whole thing. So yeah, it looks reasonable. Yeah. All right, so the next few problems just get us used to number lines. I don't really know that this belongs in this section, but it is what it is. So I'm going to take the numbers that are given for number 9 and place them on a number line. This I can't reproduce on the answers. So if you looked up for the answers right now, that doesn't exist. So to put 3 on a number line, I'm just going to find 3 and put a dot on it. Probably don't need to name it again because it's already named, but I will. To place 3.5 on a number line, same deal. It's already labeled. I probably could just put a dot on it, and that's considered placing it on a number line. 1.75 is not on my number line. 1.75, it's bigger than 1.5. It's less than 2. It's halfway between 1.5 and 2. So when I place 1.75 on my number line, I'm going to make a dot halfway between 1.5 and 2. For -1/2 or -0.5, that's already on my number line. I'm just going to include it there. For -1.75, that's between -2 and -1.5. So this is going to go halfway between -2 and -1.5. I'll make a dot and write that as -1.75. And lastly, -3.25, that's between -3 and -3.5. -3.25. Halfway between -3 and -3.5. I could talk about the number line when we get into rounding here in a second, but I think it's almost pointless. I think it's easy enough. This is going to overcomplicate the whole situation of rounding. So the next few problems are rounding. I snuck this from some Google image. It says, if I want to round to decimals, find your place and look next door. 5 or greater, add 1 more. I never heard that, but that feels pretty good. All digits in the front stay the same. All digits in behind, zero's the name. Obviously, this is from a grade school teacher. But let's look at the problem that was displayed here. It says round 1.362 to the hundredths position. So again, there's tenths and then hundredths. So when I'm rounding 1.362 to the hundredths position, this number in the hundredths position, it's either going to remain a 6 or it's going to round up. So to find your place, I found my place, which is the hundredths position. It's nicely underlined here. I look next door. If the number next to it's 5 or greater, I add 1 more. If it's not, I'm going to leave it the same. So this rounding of 1.360 is correctly rounded, although to me that looks like it's in the thousandths position. I probably wouldn't put that 0 in. I'd probably say this rounds to 1.36. The zeros aren't, this instructor put zeros at the end. Those are just placeholders. They don't have any value. They can be expunged. Similarly, this problem, 25.378 round to the tenths. So I find the tenths position. I look after that number. If the number after the position I'm rounding to is 5 or bigger, I round the number up. If the number isn't, I keep it the same. So I'm going to round this 3 up to a 4, and the person that just wrote this so much better than me decided to put zeros in. They're not necessary. If I'm rounding to the tenths position, I probably don't have numbers in the hundredths and thousandths position. So now it's just a bunch of rounding problems. There's a little bit of trick sometimes when you have nines. So for 12a, to round this number to the nearest tenth, I need to know what number is in the tenth position. And then I immediately look to the number after the number in the position I'm rounding to. If the number after is 5 or bigger, I round up. If it's 4 or less, I keep it the same. So that 5 is going to round up to a 6 because the number after the decimal forces that to happen. B of number 12 wants me to round to the thousandths position, and the thousandths is the third decimal. That's kind of why we started writing decimals at the beginning as much as anything to get ready for knowing the place values that we're going to need when we're rounding. And now if I'm rounding to that third decimal, I look at the fourth decimal. If it's 5 or bigger, I round up. Since it's 7, which is 5 or bigger, I'm going to round up. So I'm going to write 234. The 5 and 8 are going to stay, but that 4 is going to bump up to a 5. So the only number I'm rounding is the number in the position that I'm told to round, unless there's a 9, and then all of a sudden that gets ugly. Part C wants me to round to the hundredths, which is the second decimal position. When I write my answer, either that 8 is going to remain an 8, or that 8 is going to bounce up to a 9. That has to do with the number after the 8. Since the number after the 8 isn't 5 or bigger, I'm just going to leave it at an 8. I'm going to write 234.58, and I don't need the zeros afterwards. Had I paid more attention and saw those zeros, I might not have included that example because I just don't, they're not normally put, at least in a college class. D is tricky. It wants me to round to the nearest whole number. 4 is the whole number part of this. That's the number that I'm either leaving the same or rounding. And I'm not going to have a decimal in my answer because the first number I'm going to write is the number preceding the decimal. Since the number after the 4 is a 5, I'm going to round it up. I'm going to round the 4 up to a 5. I'm going to say this is 235. Such a friendly section. There's a little bit of grunge, but it's not horrible coming up in a bit here. Here's the 9s that get ugly sometimes. 14a wants me to round to the 10th, which is that position. Because the number after is a 9, I'm going to round that 5 up to a 6, and I'm going to write 79.6 for my answer. Part B of 14 wants me to round to the thousandths position, which is that position right there. I look at the number after, it's a 3, which isn't 5 or bigger, so I'm going to leave that 7 alone and not round it up to an 8. The hundredth, this is where the evilness can come in rounding. This is the hundredth position, and I want to decide whether to leave it a 9 or round up. The 7 after it causes the 9 to round up to a 10, makes me carry a 1 over to that 5 and bounce that up to a 6. So it's a double rounding. When you have to round a 9 up, you need to carry the 1 over to the next number. For an answer, because it says round to the hundredths, having a 0 in the hundredths position makes sense. But because that 0 just really not have any value, maybe I wouldn't write it. Both of these would be acceptable answers for part C. Part D wants me to round to the nearest whole number, which is that 9. Either that 9 is going to remain a 9 or it's going to bounce up to a 10 and I have to carry. And the number after it is a 5, which makes me round it up. So this 79 is going to round up, the 9 is going to round up to a 10. I'm going to carry the 1 over and round the 7 up to an 8. And I don't need a decimal because the number that I'm rounding is to the left of the decimal. So my answer for part D is going to be 80. Now, ugly. Adding and subtracting decimals. To add and subtract decimals, I just line the decimals up and add and subtract normally, other than I bring the decimal down. I don't know that that's a stellar explanation of what I'm about to do, but there's nothing to adding or subtracting decimals. It's just a matter of writing the numbers vertically, lining up the decimal places. If the numbers don't match up in size, you want them to match up in size, so we'll add some zeros after decimals, like this problem that's written on the screen, 0.32 plus 12.965 plus 1.1. If I wrote those vertically, I could see that that 965 has 3 decimals, so the 0.032 and the 1.1 need to have zeros added. I want each number that I'm adding or subtracting to have the same number of decimals. Then I'm just going to line them up and do just plain old regular addition or subtraction if it's a subtraction problem. Let me do a few of these. I kept these pretty basic because mostly I do decimal work on my calculator and I don't want to get that deep in the weeds. Quite honestly, when I was making up the key, I stumbled for a little bit. I'm so used to doing these on my calculator. So let me do 16, adding 7.8251 plus 4.3172. I didn't make any problems where I have to add zeros. I made them match perfectly. Have an addition problem. I'm just going to do regular addition. I'll go 1 plus 2 is 3. 5 plus 7 is 12, carry the 1. 1 plus 2 is 3, 3 plus 1 is 4. 8 plus 3 is 11, carry the 1. 1 plus 7 is 8, plus 4 is 12. And keep the decimal exactly lined up. So that should come out for 16, 12.1423. The next few problems are subtracting, and basically I'm going to predetermine the sign. In number 18, my answer should be negative because I'm adding and the numbers have opposite signs. But I'm not going to worry about the signs in my work. I'm just going to put the sign in my answer. And in order to figure out the number that follows a negative sign, I'm going to just take the bigger number, 18.8, without the sign, minus the smaller number, 14.2. This is going to give me an answer that I'm going to have to attach the negative sign to. So now I'm just going to go 8 minus 2 is 6. Bring down my decimal. 8 minus 4 is 4. The 1's cancel. If I stopped here and said 4.6 is my answer, that's not right because my answer should be negative. When you're adding and the numbers have opposite signs, your answer should have the sign of the larger. So I have to be careful not to choke on the signs if I'm doing this work by hand. Mostly I do these on my calculator, and then it's not such, then signs are not an issue at all because my calculator can gobble the signs straight up. If I need to on problem 20, I can rewrite it as addition. The double negative turns positive in problem 20. Don't like to see the 9s, they're going to make me have to carry. Now, it's an addition problem, but the signs are opposite, so I'm really going to subtract. In my answer, the sign should be negative because the 45, the bigger number, is negative. I'm not going to include the negative with the 45. I'm just going to subtract 45.75 minus 13.99. I'm going to do some borrowing. I'm going to go this 5, I'm going to borrow 1 from the 7, make it a 6. I'm going to make the 5 a 15. I'm going to do 15 minus 9 is 6. 6, I can't subtract 9. I'm going to borrow 1 from the 5, make the 6 a 16. Lower the 5 to a 4. Now I'm going to go 16 minus 9 is 7. Bring down my decimal. To the left of the decimal, I have 4 minus 3 is 1, and 4 minus 1 is 3. So numerically, I get 31.76. My answer, the algebra, or the arithmetic I did, doesn't show the sign that I need. I know the sign ahead of time is negative. So when I go to write my answer, I predetermined the sign. Trying to do the work to get the proper signs is disastrous when you're dealing with decimals. For 22, this is really negative 3.6 plus negative 5.9. The nice thing is these both are negative, so I'm going to add the numbers and keep them negative. So my answer again should be negative. I'm not going to include the negatives in my work because again, it just makes it harder to follow. I should know what the answer is ahead of time and know whether I'm adding or subtracting. If you have opposite signs, you're subtracting. If you have the same sign, you're adding. So here I have the same sign, so I'm adding the 3.6 and the 5.9. I add 6 and 9 and get 15. I carry the 1 over, and then I get 13, and 13 and 5 is 18. That's not right. I carry the 1 over, moron, and the 3 goes to a 4, and then 4 plus 5 is 9. Like I said, I stumbled when I did this just a second ago for my answer key, specifically because I got so lazy just doing decimals on my calculator that even that little bit carry the 1 and make a 3 a 4. I don't know why I just wrote garbage, but I did. It is what it is. And I'm going to make my answer negative because it needs to be negative. Just a few more problems and this section is over. A nice 25-minute section is nice. On 24, both numbers are negative and I'm adding, so my answer should be negative. So I'm not going to use the negative in my work. I'm just going to add the numbers together. So I'm going to do 6.7 plus 5.8. Try to do it correctly this time. 7 and 8 is 15. Bring down my decimal, carry the 1. 6 plus 1 is 7. And then add 7 and 5 and get 12. The algebra gives me 12.5, but I know the answer should be negative. So when I go to write my answer, it's just logic that gives me the sign. Last problem. 25 and 26 have double negatives that I need to make positive. So 26 is going to be 5.74 plus 4.33. Don't have to worry about any signs. There's nothing but positive signs. My answer is going to be positive. So I'm going to line these up. Add 4 plus 3 is 7. 7 plus 3 is 10. Bring down my decimal, carry the 1, and get 6 plus 4 is 10. My answer to 26 is going to be 10.07. Again, there's going to be really, really light decimals on the test. They won't come up a lot in our class, just because this is kind of a generic review of kind of an arithmetic course at the beginning of class. They want me to, introduce some things that, might come up in other classes, but we won't do a lot of decimal work in our class. So, treat this section lightly. I'll keep the problems as light as I can, kind of this light on the test. And once we get out of this section, the few times that we see decimals, well, I'm just yank my calculator out. All right, nice 25-minute lecture.